Woohoo, we are live and I'm having a little trouble focusing. Let me see if I can get it to focus. There we go. Okay, this is Math 40 and this is section 2.6 and this is the last word problem we're doing in 2.6. Woohoo! And the good news is that 2.7 is something completely different. And so there'll be a bit of a break with the word problems just for a bit. But this problem is about scuba divers. So I thought I'd bring out all of my friends who are, scuba diver like creatures. My shark, which lives in the ocean, my Godzilla, who also lives in the ocean, both in the Pacific Ocean. And then, of course, my sparkly vampire, which, if you've seen any of the Twilights, they also swim in the ocean or walk along the bottoms. Sorry, no spoilers. So we've got our ocean dwelling creatures here. And so we're going to talk about a scuba diver. And he's not actually, or she is not actually in the ocean. They are at an amusement park. And they were hired to collect $121 in nickels, dimes, and quarters at the bottom of a wishing well. Woohoo! I'm assuming it's very large. There were 500 nickels and 90 more quarters than dimes. How many quarters and dimes were thrown into the wishing well? So I'm going to claim this is a mixture problem, mixture type problem. So I set up our chart, gave myself some room to think about things. And so I'm going to go ahead and get started with collecting data for the chart. First off, put a smiley face there in the upper corner because I'm not going to use it. And then I have to think about the things that I'm going to add. And then the last one being the mixture. So I got the mixture down here at the bottom. And then the three different things I'm going to add together. Notice I anticipated. I know, I am a mammal who learns and can plan. So what are the different things? Well, I've got nickels right here. I've got dimes right there. And I've got quarters. Woo! And I'm going to follow the exact same method I used previously for mixture problems. I'm going to say total amount, but in this case, I don't say always the amount of quarters. I would say the total number, the number of quarters. You could write total amount. These headings are really for you, so that for you, where are we? For you, there we go, you. They're for you to keep track of your data. This chart is for you. It's to help you organize your data. I believe it's what is it called? A visual organizer if you were going to go get a degree in education. So the total number. And then remember in the previous one, this was the price per pound or the strength. And then I'm going to say that for coins, we don't really have a strength. We don't have a value when we're talking about money. Well, we do have a value. Sorry, we don't have a strength. We don't have like a price per pound. We have a value. So I'm going to say the value of each coin. So it's kind of like the strength or the dollars per pound. This is just the cents per coin. And then this is going to be the total value. And again, you can use different headings. If these headings you're like, that doesn't really fit for you, use a different heading. Just use one that's going to make sense. I can take the total number times the value and get me the total value. So in other words, if I have 5 nickels, I'd have 25 cents. The next thing we have to do with our chart is remember we have to be consistent. And I know that I have $121 total. So that's the total value of the mixture. As soon as I write it in as dollars, then the value of each coin has to be written in dollars. So I have to do 0.05. Dimes are 0.10. And quarters are 0.25. So if I choose to do it this way, this is the way it's going to have to go. Now, as it turns out, I do have this problem already worked out, and I will include this in the notes, and I'll let you go ahead if you'd like. You can freeze frame and take a look at this. This is how we could do the problem if instead of using dollars and decimals, if I put everything in cents, so it's 5 cents, 10 cents, 25 cents, the only problem there is that that means that I have to convert $121 into cents. And so I've got 12,100 cents. So that makes this number really large. So I will include this in the notes. You can go ahead and screenshot it right now. You can take a look at it and compare and contrast, because you'll notice this equation has no decimals in it. And of course, the way we're about to do it, it's going to have a whack ton of decimals. So it really depends on how you want to approach it. You get to choose. Both ways will work. Okay, so as I read through, I've got my nickels. So my nickels will be green. There we go, my green nickels. How green are your nickels? And I see right off the bat there are 500 nickels. Woohoo, 500. Bam, this is going to be easy. And then I look and I see, okay, I've got dimes. Now, does it tell me how many dimes there are? Well, it kind of does. There are 90 more quarters than dimes. So there's my dimes, 90 more quarters than dimes. That's going to be complicated. And then my quarters, I'm going to do that in pink. That's going to be here. So it told me how many total number of nickels there are, but not the dimes and quarters. So we're going to have to figure that out. So I'm going to write right here, 90 more quarters than dimes. Okay, so I'm going to figure this out. I'm going to use this space to figure out what I can do with this. And then it says, how many quarters and dimes were thrown into the wishing well? Awesome. So let me look at this chart. I don't know those two numbers, which is going to stop me. So I probably am going to have to go deal with this now. But let me just take a look. With a mixture, I don't have a value of the mixture coin. So this is not going to be used. I'm not going to use this. I can multiply across. So I can do 500 times 0.05. Turn it back on, clear. 500 times 0.05 equals $25. So I've got $25 there. So that's getting me part of the way towards the 121, but I still have to get these two amounts. So let me take a break here, and I'm going to go up to here, and I'm going to figure this out. So we're comparing quarters and dimes. So I'm going to put quarters on one side, and I'm going to put dimes on the other. And I'm going to think to myself, I need to put a 90 on one side or the other. And I'm going to think about the teeter-totter. And we've done this one before. But if I have a teeter-totter and I put the big on one side and the small on the other side, where does the 90 have to go? Does the 90, to balance it, does the 90 go on the big side or the small side? You're right. I put the 90 over here with the small to balance it out. Does that make sense? The 90 plus the small balances it. The big doesn't need the 90. The small needs the 90. So when I look at quarters and dimes, I think who's the big one and who's the little one? I've got 90 more quarters than dimes. So that tells me quarters are big and dimes are small. So I need to put the 90 over on the small side to balance them. So the number of quarters equals dimes plus 90. What do you think? There are 90 more quarters. Number of quarters equals dimes plus 90. Okay, so I need a variable. What if I let D be the number of dimes? Because it's the next one. And then the number of quarters is equal to what? D plus 90. What do you think? Okay. So I could add all of these together, 500 plus D plus 90. So I'm going to get 590 plus 2D. It turns out we won't use this, so you don't have to do it. What's really going to be important actually is the multiplying across. So let me try that. D times 10 cents is equal to 0.1 D. And then D plus 90 times 25 cents, oh, it's a mess. It's 0.25 times D plus 90. Okay. And then I'm going to remember that in the mixture type problems, multiply across, we set it up so we can add down. The value of the nickels plus the value of the dimes plus the value of the quarters equals the total value. Okay, so the value of the nickels plus the value of the dimes plus the value of the quarters gives you the total value. Okay, so the value of the nickels is 25. The value of the dimes is 0.1 D. And the value of the quarters is 0.25 times the quantity D plus 90. And that has to equal the 121. Woohoo! Let's go on to the next page. 25 plus 0.1 D plus 0.25 D plus 90 equals 121. So I'm going to tell you that in the past, when I have solved this way with students, more of my students just want to do this with the decimals. More people are like, you know what, let's give it a try with the decimals. So I'm going to give it a try with the decimals, but I'm going to recommend something. Given that this has 2 digits, I will probably go back to writing this as 2 digits. What does that mean? I'm going to write it as 25 plus 0.10 D, just so that they all match. And then the 25, the 0.25 is going to go multiplying through. So I get 0.25 D plus 0.25 times 90, and the whole thing equals 121. So let me get out my calculator. 0.25 times 90 equals 2250. So I've got 25 plus 0.10 D plus 0.25 D plus 20, whoops. I don't know what number that was, like 23. I think my brain was trying to round up or something. Who knows? 2250 equals 121. Okay, so let's take a look here. I see I've got some numbers, which I can combine. And I've got some variables, which I can combine. So let's see, I've got 0.10 D plus 0.25 D plus 25 plus 2250 equals 121. Remember this is the commutative property of addition. I can move things around so that I can get these two together. And then I can also get these two together. So let's see, I've got 0.10 plus 0.25 is 0.35 D, because these are like terms. Again, if you're not sure, 0.10 plus 0.25 equals 0.35. 25 plus 2250 is 4750, and altogether I get 121. So it's not too bad so far. Working with the decimals hopefully is not feeling too bad, because you know it's money. A lot of people work with money on a daily basis, so it perhaps feels a little easier than fractions. I'm going to go ahead and leave the D here, so I got to move the 4750 to the other side. Oh my goodness. I'm getting to the point Or there we go. Minus 4750, where I should probably be using a calculator because my brain is just like, no more math, please. No more math. Let's do something else. And I'm like, no, math all the time. 47.50 equals. So I get 7350 over here. And then what do I do to both sides? I divide by the 0.35. Which happens to already be on my calculator. So I just divide by 0.35 and I get 210. So 210, and let's go back to the original, there you go, the original problem. I picked D to represent dimes. So that's 210 dimes. And then it asks how many, how many quarters and dimes. So I'm not quite done yet. That's the dimes. And then I have to find the quarters. So I see here and I see here. I can look at either spot. The number of quarters is D plus 90. The number of quarters is D plus 90. So the quarters, number of quarters is D plus 90, which is 210 plus 90, which is 300 quarters. So I've got 210 dimes, 300 quarters. Now here's the thing. With this one, unlike the chemistry ones, this one's pretty straightforward to check. Let's go ahead and check it. So 210 dimes, 210 times 0.10, that's $21. 300 quarters, 300 times 0.25, that's $75. I add the $21 and I get $96. And then I see 500 nickels. How much were they worth? That was worth 25 plus 25. And I get the magical number. Can you guys see it? 121. So if I add the $21 from the dimes, let's see. I'll do it on the next page. I got one more page. I knew I had another page for something. 210 dimes equals $21. 300 quarters equals $75. And 500 nickels equals $25. So if I add all those quantities up, I get 121. And that is the amount I was supposed to get, 121. Oh my gosh, you guys, we did it. We survived 2.6. So let me say again, these are not easy problems. These are problems you're going to be working on for a couple of years as you work your way through math. You're going to get better and better at them. But this first time we're going through it, there's a good chance they're going to be very frustrating. So make sure you have your support system in place. Make sure you have something to drink. Make sure you have something to eat. Make sure you take frequent breaks. Every 10, 20 minutes, look at something else. If you've spent half an hour on one problem, take a break, ask for help, put it away, do something fun, come back to it, let your brain see it in a refreshed state. If you get stuck, ask me for help, ask tutors for help. Word problems are not easy. If you get through them, that's amazing. If you don't get through them, then that's really normal and expected. And if they're very frustrating and you just want to, that's also very normal and to be expected. You could make some, you could make a shark and have the shark eat, nom, 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 the word problem. Godzilla can stomp all over the word problem. The sparkly vampire can embarrass the word problem, I guess. Blah, blah. So, reach out, get help. Everything's going to be okay. Next section is not word problems. Woohoo. Okay, guys, you did it. Math on. Math on. You guys are awesome. Woohoo.